Yeah, so before moving on to our collab notebook, we would like to go through some concepts of Spark and PySpark. So before we learn about PySpark, uh, here's some introduction about Apache Spark. So Apache Spark is a tool for distributed computing, and it's very similar to Hadoop and also like dissimilar. So it's similar in terms of like it uses distributed computing, but most of the work Spark does is in memory as which differs from Hadoop because Hadoop works on uh, the Hadoop file system, which is mostly disk based. And yeah, and one similarity of Spark with Hadoop is that it uses distributed computing, which means you have lots and lots of clusters, and you can scale your applications for a broad range of applications. Uh, Another one is it has broad language support. For example, so Spark is written in Scala, but uh, Scala can be used through Java. But like for example, by broad language support, I mean that there are Python and R bindings available to run Spark, and one of those bindings, the Python API for Spark, which we will be learning today. And the another one is that Spark has a big data ecosystem that multiple applications can be utilized in sync with Spark. For example, the HDFS is the Hadoop file system, which we covered last time, and Cassandra, which we covered in the SQL Part 2 workshop. And these integrations with Spark helps to build lots of big data tools and frameworks. Okay, now coming to Spark, if I have to say, it's just the Python API for Spark because Spark is written in Scala. So if ideally, if people don't know Scala, then they can still use Spark using this Python API. And then they figure, this is from our previous workshop, which we discussed, that what kind of tool you should be using based on what kind of data you have. So, and then Spark is very versatile, like you can have like for 1 GB or 10 gigabytes of data, Spark or Pandas is okay. But let's say if you have a 100 gigabytes or 1 terabyte data size, then you should be having like a Hadoop and Spark cluster. And whether to use Hadoop or Spark depends on your application, which we will be looking at in like what cases you should be using Spark and Hadoop. Yeah, PySpark also allows you to use SQL queries, which we'll look at today. We'll run some SQL queries on PySpark. And another thing, we have also discussed this in the previous slide, that there are lots and lots of libraries and tools available to link Python and Spark with other kinds of applications. Okay, so now coming to PySpark, it's best for both batch and real-time data processing. And mostly wherever you need faster execution times, it uses everything runs in the memory, so everything is very fast compared to Hadoop, which runs on drive. And since it supports SQL-like structure for querying, we can build complex data pipelines which uses aggregations like group by and joins and functions. Okay, now coming to comparison between PySpark and Hadoop. So like I said, Spark is in-memory processing, which is different than Hadoop, which uses a disk-based processing. And and PySpark and Spark offer high-level APIs in Python, Java, Scala, and R, which it's like lot. So if you don't know Java or Scala, then you shouldn't worry about it because you can use Python or the R API to connect to Spark, and which makes it more accessible than Hadoop's MapReduce. And then similar to last workshop, we saw that since Hadoop is written in Java, then we were using Hive to connect uh, because Hadoop requires to have a Java code, but if you don't know Java, then you can still use Hive to connect to your Hadoop uh, data sets. And another difference is in the real-time processing because Spark runs things in memory, then it supports real-time processing capabilities, whereas Hadoop is just for like batch processing because it runs on the disk. Okay, and this is summary based on different criteria. Let's say data processing, data storage, and processing types. So let's say if you have like very, very high, large data sets, which you may or may not fit into your available memory, then going with Hadoop, which would make more sense. But if you don't really, if you have a large memory and your data set size is small, they can use Spark to fit everything into like working memory to run your jobs. Okay, next, going to complexity of operations. So I would say both are equally good because for Hadoop we have Hive query language which supports SQL, and again PySpark also supports SQL queries. Okay, with respect to cost, and so it's like if you have a very large data set, so you can just store and run things. For example, data warehousing or historical data analysis or some kind of ETL jobs, you can use Hadoop. But you should be using PySpark uh, when you have, let's say, relatively smaller data sizes, or if you can process them all into memory, then you should be using Spark wherever you want to do real-time data processing. Okay, any questions till now? Yeah, if not, then we can move on to our tutorial on Colab. So yeah, people are just join Zoom. Can you just give me a thumbs up if you were able to open this notebook? Yeah, thank you. Okay, we can get started. So first, yeah, so first we'll download the data set here. Okay, and it's the same data set we were using, the COVID-19 synthetic data set. We have used the same data set in our SQL and in the Hadoop workshop as well. Okay, so now if you refresh, you'll see a PySpark underscore data.zip. So this zip file contains four CSV files, and if we unzip this, should be having those four CSV files available. Yeah, so once we have unzipped all the CSV files, like we can see here, all the four CSV files are available here. Then we'll get started with installing some libraries to run our Spark. And since Spark is based on Scala and Java, so we will need this OpenJDK here. So by running the next command, you can install OpenJDK. Yeah, next we will install Spark. So right now we are downloading the Spark from the Apache Foundation's website. And now we'll extract the Spark application. Yeah, so if we refresh here, you should be seeing this folder Spark with the version number, with the Hadoop version number. And now we'll install PySpark. It's done now, and then so what we'll do here is set up some environment variables for Java and Spark, and then make a Spark session using this PySpark.sql command. And just based on your use case, you can name anything here. For now, I've just named it as PySpark tutorial, but if you're working on some other data set, you can have rename this and have its own session. Yeah, so before loading CSVs, I'll wait for you guys and please let me know if you are done till this step. It just gives me a thumbs up on Zoom. Okay, so now we'll load these 4 CSV files, and these CSV files are same as some of the tables in the which we have used in the DuckDB SQL workshop. So instead of the whole database, right now we have just 4 CSVs as samples for this tutorial. So we'll start loading these. And this command is similar to the pandas read CSV command, that you want to put all of the data into memory. And it also has like some arguments such as header equals to true, which you will also find in your uh, pandas read CSV function, which converts or reads the data from a CSV file and converts into a data frame. Yeah, so what is infer schema is true that since we are uh, loading the tables into the data frames, we are not telling it that based on the columns infer schema. So once you run the next column which says print schema, you will know that okay, uh, we haven't defined the data types for each column, but the program automatically infers that what data type is present in which column. So if you run this next command here, which says print the schema for each data frame, and if you run this, we didn't say anything that, let's say for patient DF, we didn't specifically mention that the ID should be a string and birth date and that date are the date types, and then all other things are string, but then the healthcare expenses are numbers like double. So now we are telling that, okay, Spark should be able to infer this on its own instead of we specifically mentioning the data type for each column. Does it answer your question? Yeah. So moving forward, yeah, so this command print schema will tell you like what are the columns, what are all the columns present, what data type they have, and so on and so forth. Again, for medications, immunizations, and observations data frames. Or here, if you just call the patient DF here instead of calling print schema, it will just show you all the uh, again all the columns, but in more like a row-wise format. That is starts with like a data frame and then just prints out each column and what data type it holds. Yeah, so these are similar to describe and then the table name command in SQL. Okay, moving forward, from here on, we'll have all the commands which are similar to SQL. So, and then also similar to pandas here. So, for example, if you want to know more about patient's DF, in pandas, you will do like DF name dot head, and then in the head parenthesis, you will put like how many rows you want to print. So this is also similar, that if you just say patient DF dot show 10, it will show you the top 10 rows for the patients. Okay, same thing goes for the medication and immunization and observation tables. And whatever commands we're going to learn is everything is like possible in SQL and pandas. It's just that Spark provides you like an alternative way to process things. And right now, this data set is small, so you may not see a big difference between the processing times. But once you go to, let's say, processing like terabytes of data set, then the actual difference uh, comes in while running queries. Okay, so now I'll start with the select operations, that how can you filter these data frames based on some criteria. So right now we are not filtering anything. We're just trying to select the first name, last name, gender, and city. And the question could be that query the patient's data frame and display first name, last name, gender, and city, the level. So you run and then say, okay, and that's how you can get the specific features for patients in the patient's data frame. Okay, next is count. Uh, and so if you look back in the SQL tutorial, it's in the same order as the SQL tutorial. Like if you go here and open the SQL part 1. So once you start with from here, select, so each command here is equivalent, are equivalent commands in Spark. So it's just providing an like an alternative way of running things. So for example, we want to know the number of rows in patient's table. So what we can just do like a count method on the DF, and it will tell you, okay, there are like 124,000. And then it was the same here in the SQL tutorial as well. Okay, count and distinct, that you want to know uh, distinct cities and how many patients are there. Oh, no, right now just want to know how many distinct cities are there. So we run this, that we filter out the city column, put a distinct, and then count. So now we get like 351, and which matches our results from our SQL tutorial. Okay, moving on. Let's say we have a query which asks you to return unique combinations of cities and genders. So now you can put distinct on multiple columns like city and gender both. And then you will have city and then gender, and they are in just like some random order. And this will not match because the order was randomized. So if you go back and look to our SQL queries again, they are also in some random order. Okay. Yeah, now comes the use of where, that how do you filter based on specific criteria. So now you want to know all the patients who live in the city Springfield. So what you can do, you can start with the DF and then select all the 4 columns. But now you want to filter on this city column, wherever city is Springfield. So this is similar to having uh, the SQL command of like select city, first name, last name, gender, and city passport from where city equals Springfield. So these both are equivalent commands. Uh, and then when we run this, we'll get like a similar results from the SQL as well. So in this way, if you are not sure of running any command, you can always go back and look at your look the SQL tutorial, that if the command you ran in Spark produces equivalent results or not. Yeah, so from now on, we'll probably assume that whatever command we are running in Spark is equivalent to the SQL and we'll not look at the SQL workshop. Okay, okay, moving on. Yeah, moving on, we have an example of multiple selections. So instead of just saying that we want to know for all the patients in city Springfield, we would like to know all the patients in Springfield and their gender is female. So we can do a filter on multiple conditions, similar to a SQL query. And then we can also have nested selections for female patients having for city Springfield and Boston. So this is the or operation for PySpark. Here it's saying that either in Springfield or in Boston, but all the patients should be female. And once we run this, okay, and then there's another way that uh, since yeah, so instead of writing that city in Springfield or Boston, what you can do is the alternatives use this uh, is in function here, very similar to what you have in pandas, that you put the data frame name, the column name, and is in, and then instead of like a tuple here, you will have like a list in pandas, which contains whatever criteria you want to match. Okay. Now again, like how do you Spark processes NaN values? So this is one example where you want to know all the patients who don't have a passport number. So, and then they are in the city Springfield. So right now what you can do is use this filter on Springfield and then use this AND operation. And for the passport, you can use this function which is not null, which means that which will return all the patients who have a passport number in the database. Okay, right now we would like to know all the patients who have null in their passport. So instead of is not null, we can use this is null function here, and which should return all the patients who don't have a passport number. Okay, and here's an example of numerical filtering, that you want to have those patients in the city Springfield having their healthcare expense between 1.5 million to 2 million. So again, this is you can use the greater than equal to or less than equal to functionality here for each column. Yeah, once you do this, you'll get these list of patients. And also you can limit the number of results. So for example, default, we are seeing that if we don't have a limit inside our query, by default it shows 20 rows. But since let's say if the data is big, then we can limit. So right now we'll have limited DF and let's say just want to see 10. Yeah, so if we all just want to see top 10, then it will just show you the top 10 results. So using the limit function, you can limit how many number of records the query will return. Okay, now comes the order by and ascending. So now we would like to sort the entries based on some criteria and uh, how many. So in what order you want, either ascending or descending. So here the command follows that we have the data frame, we are selecting the 4 columns here. And now we're using this order by function, saying that whatever result you're getting from this part here, order that result by the last column, and ascending should be true, which means that all the abbots which comes in higher in order and alphabetically should be together. And then we have this limit 20. I mean, you can have any other number here. Let's say limit 30. So now you will have a bigger. Oops, element. So you can limit the results here. Okay. Now, for example, order by in descending. So we use the same function order by, but right instead of ascending true, we'll put ascending false. And now the table or data frame will be sorted on the first letter of the first name. And since this guy Oscar has a special character O, that's why it's sorted. So based on the ASCII notation of the first letter of all the names, this O with a special character is the last letter. Okay. Okay. Here's a question. If we have one column ascending and another descending, how do you sort? I think you can have another order by here after this result. So let's try this thing. Okay, let me have one more code. That's a good question. Let's try this. I'm not sure if this is gonna work. Yes, Karan?
Yep. So you're going to present the information based on the order of one column, and if you want to say following the descent of these, probably
It might change, right? So
yeah.
so should we mention both? Yeah, maybe. Yeah, I'm not sure if we can. Yeah, let's try this.
On the last,
Yeah,
so then to last and first go together, and probably
maybe this will not work, I think, but there's no harm in trying. Nah, it's still giving the same. Okay, yeah, this is wrong actually. Yeah, I don't know the answer to your question right now, but yeah, probably by the end of our tutorial, we'll get to it. Okay, where we were here, right? Okay, so let's start or resume our tutorial with aggregating data. And now we are looking at counting patients. So here the syntax differs a lot from SQL, that now we are using this special functions from PySpark.sql, like we discussed in our tutorial, that PySpark has flexibility for having aggregations or joins and window functions. So that's what I meant, that PySpark has this SQL submodule here, which has some functions inside to run SQL queries. And right now, what we want to know, counting patients based on city. So what we're doing is having this patients TF, and now we are doing a group by based on city. And now we're aggregating everything based on count, and then putting this alias on the results, returned results, saying that as patient count. Once we run this, should give us, yeah, all the patients, like how many patients are in which city. Yeah, and doing the same thing, we can use this ascending or descending to sort those counts here. Yeah, so like, and this matches with our results in SQL that Boston has the highest number of patients. Okay, now if we want to have uh, double grouping based on like city and gender here, so we can group by both using city and gender, then have a aggregate count, put an alias to the returned result as total patient, and then again order by the total patients here. So yeah, it should return result that. okay, Boston, and then in the previous query, the Boston results were together. There was no gender specific results here, but in the next one, we do have gender specific results. Okay, yeah. Okay, now we are looking at another table, which is the observations table, which has data about, let's say, since this is the COVID-19 ICU synthetic data set, we have uh, blood pressure, heart rate, respiratory rate, body height, weight, body mass index, all the patient characteristics related to one specific patient. And we can also look at, like we looked at in the start of our tutorial, that how do you explore other tables? We just call the print schema function to know, okay, what columns are available here. Okay, so moving on. Uh, let's say we would like to know what is the average heart rate by patient. So what we can do is select the data frame or the table here, do a filter, and since it has this description, it has so many text related. So we are using like a matching operation where you're saying that, okay, uh, whatever the value inside the description column, we would like to filter all the filter the description column with the entry should look like this, like heart rate. And then we are casting the values inside once we filter these, we are casting these value as decimal and then grouping based on the patients, because there could be like multiple entries for each patient in different encounters. Now we're grouping on patient and we are rounding off the values to 2 digits after the decimal and putting the alias average heart rate, and now we are sorting them based on the descending order. Yeah, so this is a long query, but it might take some more time to run. It might take some time to run. Where did it run? Let me check. Yeah, I think it ran. So it's telling that, okay, it's now this is different patients, and then we have the average heart rate for different patients in descending order. Okay, we can also count how many records are present for each patient here. So we start with the same, we have the table name, we now will filter on the description column, and the value should look like this string. And once we have those results, we can group them on the patient column, count them using the aggregate function, put an alias as heart rate records, and then order them in the descending order. Yeah, so now we have the results that based on different patients, how many heart rate records are there for each patient. Okay, now we'll look at the immunizations table and see patient encounter. So this table describes what kind of vaccines or immunizations each patient got for in which encounter. Okay, now we can ask this question that what are the total cost of vaccinations per patient? So we'll pick the immunizations DF, group everything by patient, and now we'll sum the base cost for each patient and then put the base cost, an alias name called total cost, and then order by on the total cost column. And we see that, okay, for each patient there's like 2,810 as the total cost for many of the patients. Yeah, it may or may not be true since this is a simulated data set. Okay, now we would like to know, okay, what are the topmost 10 common? So instead of doing a sum on the base cost, we can just look at the count of how many times these are repeated, which will tell us that, okay, this vaccine was given the most number of times. And we find that, okay, this influenza vaccine was given the most number, is almost like 10 times more than the second number. Okay, now we'll look at joins here. And I think if you look back to our SQL workshop, we have a very like a deep discussion on like what joins are. So right now, for example, for all the example, let's say for the left table, we have patients and right table, we have immunizations. So one example of inner join would be that for return all the rows where there is at least match in both tables. So then what we would do is find that one key which is present in both the tables and find the matching records. So we'd like to know, okay, which medical treatments have been administered to patients and then the cost of the medications. Yeah. And why we are doing this? Because in the patient's table, we do not have information about the immunizations, but in the immunizations table, we just have the patient ID. We do not have any information about who the patient's first name and last name is. So to extract that information, we need to get a inner join for both the tables here. Yeah, once we run this, we have, okay, like this, there are lots of people with first name Aaron and the different last name have these vaccinations and the cost. Okay. Yeah, going to left join, this returns all the rows from the left table and the match rows from the right table. So the question would be that for all the patients in the left table, since patient is our left table, what treatments they got. So what all kinds of vaccines they got. And once we run this, we see that, okay, for all the patients here, we have like some kind of vaccines available here. Yeah, now we'll look at the right join that uh, for all immunizations recorded, which patients received them if identifiable. So this will focus more on the right column that for each and every vaccination present, what are the different patients who got that vaccine. So right now, since we have just 20 rows, we have this DTaP vaccine given to uh, different patients. Okay. Yeah, the next is full join, uh, which is like a comprehensive match. It says that what are the complete list of patients and their immunizations, and for some it may or may not be present. Like for example, this Aaron or like this person didn't have any matching entry, or this person doesn't have any matching entry. But now you would like to know like do a full outer join, which means just get all the patients and immunizations together. Okay, next is cross join, which tells you like all the possible combinations of patient immunizations. And sometimes it just may not make sense because it might give you like repetitive results. Okay. Yeah, next is self join. Like if you have the same table and joins of one question, you can ask that, okay, which pair of patients are from the same city? So for that, you need to make different data frames with a different alias. So patients A and B, these are aliased versions of the same data frame. Since because we are doing a self join on patients table, and now we would like to know, okay, which patients are from the same city. So if we run this, we'll get like a list of patients who belong to the same city. It might take some time to run. Yes, meanwhile, you can go and answer the question of like multiple sorting, I guess. Okay, let me try. I think it's like order by column, and then since we have, let's say, multiple filters, column first, and then it should run, I think. So let's see if it ran. That's still running. So we can go back and look at our, yeah, let's wait for this to end and then we can look at our multiple order by function. Any questions till now? Yeah, so now it ran and it just gives us like all the patients belonging to the same city, Abington. So this is, and if you sort just based on city and put the filter name as Abington, then you will get like a list of patients belonging to the same city. Okay, now we can go and look at our, yeah, I think that's how you can have multiple order bys here that, so what we are doing first is that we are ordering your first column. So in the order by, we can have, we can mention, okay, which column to pick. So the first column and put it in ascending order. So and that's how we have all the errands coming together. And now once it's done, we can have put like a comma and say next order by we want that you order all uh, the the last column, keeping the first fixed and then keep it descending. So now what it did is that since these errands are together, but among all the errands, it rearranged the entries based on the last name now. So we'll see. And since we have mentioned descending, so we have started from W here, then V and going down. So let's say if we change here to, let's say, ascending, then if we run, then we see like all both. So now we can see all the Aaron Abbott, Aaron Anderson. So now we have multiple order buys. Uh, yeah, I hope that answers the question. Yeah, so I mean, you can have more filters here. Let's say you want to again filter or do an order by on city, so can put one more. Let's try that. Okay, now we'll put one here. City. Did it work? Not sure if it worked. And yeah, I think it didn't work. I think it's, I just leave it here. We have still some more stuff to cover. Okay. Okay, and also, so now we'll look at subqueries and nested selects. Just quickly wrap these things over. So Spark also has this feature of having subqueries and nested selects, same as SQL. And once, let's say we want to know, okay, for all the patients who have a prescribed medicine with some base cost higher than the average base cost. So you can go step by step that first calculate the average base cost from the medication data frame. Then you can filter based on the average base cost, and then again say wherever you have this, I do a join and then select first and last. Okay. Okay, next you have correlated subqueries that you can find patients whose healthcare expenses are higher than their average expense in their county. And so here also you can go step by step. So, so this tells us that instead of, so in SQL, what we write is like one big query, but right now with Spark, just to simplify things, you can go step by step that first you calculate average expenses by the country, then you find all the patient with find patients, average expenses for each patient, and then you can do uh, like a filter on patient, average expenses of each patient here. Okay, and instead of the county, similarly, we can have city here. So same step goes, first we calculate the city average coverage, then we have patient with city average coverage, and then we do a filter wherever this patient having healthcare coverage more than the average coverage in the city. And after those filters, can find the list of patients here. And Spark also has this string functions on concat, similar to SQL functions. That let's say now you want to make a single column which you can name as full name, which contains both first name and last name. So you can have this f dot concat underscore ws. You can use this function to concat the first name and last name of each patient here. It can also return the data length. So the function is called flength. So right now you want to know, okay, what's the length of the first name of this person? So you can call this flength function here. Okay. Another is this expr function. You have to tell, okay, what function you want to use, substring first, which means you want to use extract the first 1 to 5th letter of the name. You just want to call it initials. So that's how you can do it. Same thing goes with your last 6 characters. So yeah. So right now what we are doing is for first name, we want the first characters. And then for the last name, we can have these last 6 characters here. So using this function, the right, you can get it. Next is lower and upper. This is also have this function f lower and f upper to convert strings from lowercase to uppercase and uppercase to lowercase. Okay, there's left uh, trimmed address that instead of uh, some, let's say some letters in the address, you want some space or something cleaned up. So you can use this left trim, and then you can have regex replace. That initially we saw that each of the patient's name has some number associated, but now we would like to replace those numbers with some empty strings and then join everything together. So we can have this f dot regex replace function to clean up the names. Yeah, we can have this replace function as well here. So for example, uh, the patient has address, let's say 813 Casper Street. Now you want to have replace street with just ST or avenue with AV. So that you can also do using this regex replace function. Yeah, and then if you just want to have substring, so this is similar to the left function here, that if you want to have a small part of the patient's name separated out, then you can have the substring character substring function. You can use this. Yeah, that's it for today, guys. Yeah, thank you for listening, coming to the workshop.